A very pleasant afternoon to you, students. How are you doing today?
Doing okay, sir.
Good job.
Good evening.
All right, so remember that we're taking notes, and this is one of the things that we started off, that I ended the class with last week. So I'm just gonna start off with it. I trust that you are doing well. I know there still exists some timetabling issues. I'm not sure if you guys are affected by it, but I know there are other students that are affected by some uncertainty with the timetables. So if you fall into that category, I sincerely apologize. We are having a matter resolved in the shortest possible time. In a meeting today, it was discussed that by the end before the end of this week, it will be sorted for those who are affected. Go ahead.
Hello, sir. Afternoon. Sir, sir, I'm coming.
Sorry, I'm not hearing you. What you saying? All right, so let us see how best we can go through as a refresher, because we really need to be hitting the road running. Are you all hearing me?
Yes, sir.
Yes, sir.
Right.
Yes,
yes, sir.
Nice. When I said good evening just now, or good afternoon, only one person I heard. All right, so so we looked at the intuitive approach last week, and then following the intuitive approach, we looked at the calculations approach, or the algebraic approach. And we recognize that the algebraic approach or the calculations approach is the best approach to use because it is so much quicker and faster. But the intuitive approach is very important. It has specific importance for when we get to other areas of the limits. And I really hope that you guys have not disassociated yourself from it. For those of you who may be joining for the first time, yours is going to be the responsibility to get the notes, and also to access the recording. Is there a WhatsApp group? There is a WhatsApp group, right? Yes, there is a WhatsApp group.
Yes.
Good. So for those of you who need to be connected to the WhatsApp group, you can just drop your information in the chat. My able admin will get you connected. In the description is the address for my YouTube channel where the recordings were placed. You can access those recordings asynchronously. So let's go. So you're asked to evaluate the limit of a function, and it says as x tends to 3. The limit as x tends to 3. I just bigifying this thing a little bit. The limit as x tends to 3 of x squared minus 5x plus 6 over x minus 3. For the calculations approach, remember the idea here is to assume that x is equals to 3. Now, anywhere in the algebraic function you see x, you're going to substitute 3. Is that clear?
Yes, sir.
Yes,
All
sir.
right. So I'm going to have, if you follow my, let me see if I can. Spotlight. So I have x squared, so it's going to become 3 squares minus 5 times 3 plus 6. All over 3 minus 3. Now 3 squares is 9, and 3 times 5 is 15. That's minus 15 plus 6. 9 minus 15 is negative 6, and negative 6 plus 6 is equal to 0. And 3 minus 3, of course, is equal to 0. So I have a form that is indeterminate. It means that I cannot evaluate the limit of the function as it is. There is something that is preventing the true limit of the function to come out. So I have to do one of 3 small processes: factorization, rationalization, or simplification. And I look at my numerator, and of course the numerator is what is in top or on top. I'm going to factorize my x squared minus 5x plus 6. Now that is a trinomial, a quadratic expression. And remember what we did, what we said, we're multiplying the coefficient of x squared by the constant. So 1 times 6 is 6. I need 2 numbers. When multiplied together will give me 6, but when added will give me negative 5. And I recognize that negative 3 and negative 2 are the factors. So how so? When I multiply negative 3 by negative 2, when I multiply 2 negative numbers, I get a positive number, which is what I wanted, because the coefficient of x squared, which is 1, times a constant 6 gives me 6. So whatever numbers I get must give me that product. But when I add those factors, I must get the middle number. And negative 3 plus a negative 2 gives me a negative 5. Sir, what if all but one of the conditions are met? Unacceptable. All the conditions must be met in order for us to do our factorization the way we are asking. I'm asking you to do the factorization. So having found the factors, we're going to be grouping and putting 2 terms in one bracket, and that's why we had to break it up, because we had 3 terms, and there's no way I could put 3 terms and get two different parentheses with equal number of terms. One will have 1 and the other will have 2. So I had to break up my middle number into 2 terms. But breaking up the middle number is very systematic. All right? And this I know you would do from CSET mathematics or foundation concept 1, 2, 3. Really don't know why I'm spending time on that, but I'm just explaining for those who may have forgotten. So I'm grouping, I'm leaving my middle sign out every time. When this middle sign is out, it means that the last sign that is here is going to be flipped. You notice this was a positive 6, and right here is a negative. It still remains a positive 6 because when I multiply this negative 6 by the negative sign that is outside the parentheses, multiplying 2 negative numbers give me a positive number. Besides, whatever sign that is here has to be the same sign here. Why, sir? Thanks for asking. I'm going to ask myself the question, what is common between x squared and 3x? My answer is going to be x. What is left?
Sir?
Yeah. Somebody's saying something, so that's why I stopped talking. Who was that?
I'm going a bit fast. I missed what you were saying.
Oh, I'm going a bit fast. Okay. So what I'm saying to you is I'm asking myself the question, what is common here that is common here? What are you seeing that is common, Cole? Nikki?
The camera, tell them that their microphone isn't, the microphone signal isn't strong.
Hold on. Nikki?
Can you hear me?
I'm hearing you better now, hon.
Are you able to, are you hearing me now?
Yes, yes. Háblame. Talk to me. What's up? You're muted. Nikki, talk to me now. All right, let me just go over again. Let me go over again. All right, so what I'm saying to you is, having grouped my numbers, my terms, why am I talking about numbers? Having grouped my terms, this is what is happening. I am putting 2 in one bracket and 2 in another bracket. So does it matter which 2 goes in one bracket? No. If I wanted, I could put x squared minus 2 here, and I could put a 3x right there. It really doesn't matter. It really doesn't. All right. So when I group my terms, I'm now asking myself the question, what is common between x squared and negative 3x? And I'm hoping that your response would be x. So because x is common, I'm taking the x out. I'm taking the x out. And when I take the x out, what is going to be left? I'm removing one of the x's from x squared, so I'm going to have x left. I'm removing one of the x's from negative 3, or moving the only x from negative 3x, so I'm going to have negative 3 left. So this is how we factorize. When I look here and I look here, I'm asking the question, what is common between 2x and negative 6? And your answer should be 2, because 2 is a factor of itself, and it is also a factor of 6. So I'm going to factor out my 2. What is left when I take 2 from 2x? If you say x, you are correct. What is left when I take 2 from 6? If you say 3, you are correct. Now, I want you to look at this very keenly. Do you now recognize that in your parentheses, you have x minus 3 and x minus 3? So therefore, the x minus 3 is now common. So I'm going to take it out. What is going to be left?
Sir?
Go ahead.
Sir, all right. How you say you get that negative 3? The x minus, yeah, in that line. Yes, sir, that line. The negative
Right.
3. How you get that?
How many times can 2 go into 6? Into negative 6?
Okay.
Nice, very good. So now, when I remove this x minus 3, I'm going to be left with this x. See it right here, so? And I'm going to remove this x minus 3 from here, I'm going to be left with negative 2. See it right here, so? So this will be my factorized term now. X minus 2 times x minus 3. So what I'm saying to you, another way of writing x squared minus 5x plus 6 is going to be x minus 2 times x minus 3. In the factorized form. In the expanded form, it is x squared minus 5x plus 6. In the factorized form, it is x minus 2 times x minus 3. So I'm going to replace that for the numerator. I'm replacing it for the numerator, which is what I did here. Remember, I still have my x minus 3 in the denominator. So what I can say to myself now is that I have found and isolated what it is that was preventing my true limit from coming out. You see, there is no way a 0 can exist in the denominator. It means that our function, or rational function, is going to be undefined. You cannot have a 0 existing in the denominator. It makes my rational function undefined. So when I cancel out the x minus 3 from the numerator and the denominator, I'm only left with x minus 2. That is now simplified. So I'm going to go ahead and substitute my assumed value of 3 into the function, and 3 minus 2 is 1. So that limit actually tends to 1. Are there any questions? That's a revision, you know. That's a revision from last class. Question to you. Are you seeing it?
Yeah, see.
Yes, sir. See you before you get the answer.
Mm-hmm.
Yeah, cause sir,
Mm-hmm.
I tried doing some of the questions then by myself,
Mm-hmm.
and I get very different answers compared to when I use a calculator.
Compared to when you use a calculator. What do you mean by when you use a calculator? Explain.
I mean, that's like a question like this, for example. I wrote down the method and tried to solve it for myself. Even though the answer is there.
Mm-hmm.
I did that. I remember that there are calculators that deal with specific topics. So I tried looking up limitations.
Mm-hmm.
I tried looking up one of those calculators and inputted the question.
Mm-hmm.
And when I got the result, cause this was one that I gave you the steps. And when I tried looking at it, it was confusing me because the answer was wildly different from what I wrote down myself.
Okay, what calculator is that? Something that is online?
Yeah.
Okay. All right. So thank you for raising an issue that I needed to talk to the class about, but I was going to raise it just now. I was going to raise it closer to exams. I'm very aware of those online solvers. And you have to be very careful of those solvers. I'm not saying that they don't work, but you have to be very careful. Best believe when I give you a question, I have seen where students would have used it. And I've seen where students end up failing because of using it. How do I explain this now? Whereas I am one who often say to students, look at variations in answering your question. I know one person said that, sir, we learn one method here, and then when you look at Editors does another method. And I said to you, that is perfectly fine. There are several ways to skin a cat. And when you think you have exhausted all the ways, there goes another way. All right? But what I'm saying to you is that your methodology must be plausible. What I'm going to ask you to do, in as much as how you look at different methods, what I'm going to ask you to do is just to follow my steps for now. Not just for now, always, but to follow my steps. And I'm going to tell you why.
This was something that I noticed from, like, say, the first year.
Yeah, man. You see, when you talk about math book to read, I think you, Coswell, was saying that to me too. When you talk about math book to read, it will throw you in depression. It will throw you in depression because it will speak some highfalutin terms way above your heads, and you don't have a clue what to talk about. You are more confused reading than it is just sitting and just listening to me talk. But when you listen to me and I explain the matters, then the reading becomes a little bit more useful. Then, sir, what you want us to read ahead for you on Editors, that's the point. I want you to read ahead. And then when I come to class now and do the explanation, I'm sure you're going to have the aha moment. Aha! Now this is what they were talking about. All right? One example. You go to the doctor writes a prescription, and you look at the prescription, you don't have a clue what upon the prescription. But when you come to the pharmacist, those pharmacists have a decoder. And when they decode the stuff, they give you the medication, and then sometimes they don't even write it, it's printed. So you can see it says, take 2 times daily before or after meal. Decodes it for you. So I want you to just trust the process. Please, just trust the process. All right. But that's very good though. Very good to know that at least you have tried. I was going to ask the question, how many of you actually went through the set of notes that you didn't say thank you for? But I said to myself, leave that alone. All right, let me just go through this one example.
Just a question.
Go right ahead.
When I go into Edicosoft, there are things I'm unable to access anything there.
You serious?
Yes, sir. When I open it, it's showing me that something is opening, but nothing come up.
Yes,
I'm not sure what is happening.
I know why. Because when you first log on, you did not get all 5 green ticks. You got a red X that pop up.
Yes, sir. That's true.
Yeah,
there's a red X there.
And that's a problem. That's a problem. So you have to you'll have to do the, what do you call it now? Give me 1 second, please. Hello, miss. How are you doing? I'm in class here. Oh no, class started at 5. You leave campus already? Are you serious? So that means that pre-calculus class will have to convert it to a foundation class? Oh, Jesus. Oh, God. Absolutely. Oh my goodness. All right. When I finish the class ends at 7. Wow. All right. We need to do some mapping. So after this session, I'll touch base with you. You don't have an online class tonight? All right. After this session, I'll touch base with you. All right. Cool. All right. Forgive me, students. I'm team lead, and that was my assistant calling me to give me some classroom developments on campus, read some sections. The timetable issues again, so please forgive me. I may have 1 or 2 of those disturbances, in another couple of sessions until everything is normalized. Forgive me. All right. So let us look at number 2. And I want you.
Sir, remember you were helping me.
It's true. When you reach my age, 16 years old, these things happen.
It's true.
So what you're going to have happen, Lottie, is you're going to when you log on, you're going to look into the search bar that says Educosoft. You're going to look to the end of that search bar. You will see a blue and white box with a little red cross in it. You're going to click on that.
It wants say pop-ups were blocked on this page.
Good. So click on it and it's going to say always allow from Edico. Click always and click
always
done.
Allow pop. Yes. Yes,
and
sir.
Then click check again and hurrah, everything should be fine.
Yes, sir. I get it now.
Got you. Got you.
Thank you very much.
No problem, hon.
Okay.
All right. So
Sir,
let us
just
go.
before you move on, sir.
Uh-huh.
Sir, just before you move on,
Go
you see
right
at the
ahead.
top, the second line, the x minus 2 in bracket and the x minus 3. Yes, sir. Can you explain how we get that again?
All right. So what I'm doing here is I'm factorizing. I'm looking to see what is common, and then I'm going to take it out. I'm looking to see what is common, and then I'm going to take it out. So let us look at the line before that. Let us look at this line. Let us go from here. So at the start. The method is to multiply the coefficient of x squared by the constant. The coefficient of x squared is a number in front of x squared. The number in front of x squared here is 1. So I'm not seeing a 1 there. Trust me. If you look very clearly, you'll see the 1 right there. Sir, x is equals to 1? Absolutely not. When you're looking at a variable, like you'd look at this variable x, what is the coefficient of the variable is a number in front of. What number is in front of this variable? -2. What number is in front of this variable x? -3. What number is in front of this variable x? -5. What number is in front of this variable x squared? 1. So we don't normally write 1x. We just write x. And when I'm moving to integration with you, you will see me giving you one of those rules and say we don't say 1x dx. We just say x dx. It's like you are saying the rain is falling. Or, sir, can you repeat that again for me, please? You know, it's redundant. So you don't have to put the x, the 1 there. Then if you put the 1 there, sir, will you mark it wrong? No. But I want you to recognize that there's a 1 here. So the point is, I'm multiplying this 1 by the constant 6. 1 times 6 is 6. I need 2 numbers. When multiplied together will give me 6. But when added will give me a positive. A -5. So it's going to be 1 times 6, which is equal to 6. Now what I'm doing, I'm prime factorizing in order to find my factors. Prime factorizing means that I'm using my prime numbers. The first prime number is, hello, a big school mathematics, not calculus. This is a little school math, serious? So one time I do it, you don't know.
2.
The first prime number are 2.
2.
1 is not the prime. Right, very good. 2. So 2 into 6 goes?
3.
3 times. Good. Can I use 2 again?
No, sir.
You
can use it, but you get a remainder.
Right, and I don't want a remainder, so I can move on to the next prime number, which is 3. And 3 into 3 goes?
1.
So watch this magic now. Them 2 number here, when I multiply them, I will get 6. Talk truth.
Yes, sir, you will.
And them 2 number here, the top and the bottom, when I multiply them, I will get 6. Talk truth. All right. So I can say that my factors are either 6 times 1
or 2 times 3.
Yeah, but remember, say I want a -5. So in order for me to get a -5, one of them supposed to be negative. But hold on. But sir, if you put a -6 right there, so when you add it, you're not gonna get -5. Yeah. But when you multiply it, you get a -6. You don't want a -6, you want a +6. So now, when you put a -2 and a -3, when you multiply those 2 negative numbers, you always get a positive number. And when you add -2, you're going to get -5. Remember, it must satisfy all the conditions. So now you know that your factors will be -2 and -3. So it's not a random guess that you're just going to randomly select some numbers where you want 5, so you're going to be either 4 and 1, because 4 and 1 can't work. 5 and 1 can't work either, because 5 times 1 is 5, you want 6. So you have to follow the process, all right? And then now, to group, I am going to just drop the brackets. Watch me. Bam, bam, leave out the middle sign, bam, bam. But when I factor out a negative sign, remember say, that sign you have to change, you have to flip it. Remember to flip. So why? Because when you multiply these 2 numbers, it's going to be equal to a positive number. Then I multiply two negative numbers, I get a positive number. Tell me if you don't understand it.
Where to flip?
Are you understanding?
Yes, sir.
All right. One somebody. Is there anyone in the class that is not following what it is that I'm doing?
Not following is
I'm following, sir.
All right, thank you, utterly. Nikki, where you say a while ago? You're not following?
oh, you got the one.
Oh, me get the one. Which one, Nikki? The one under the
Yeah,
tree?
you said no, for the answer, you said the answer will be X
We not reach us yet.
going to
We not reach us yet. We come though, man. We soon reach us, honey. We not reach us yet.
R.
Good. All right then. So I'm happy that you're following so far. Good. So I am going to be saying now what is common here that is common there. And you can see that there's an X here. So I want X here. So I'm going to factor out the X because it's common. What is left? Is that me saying X times X is X squared? So that means one more X is going to be left. And X times negative 3 is negative 3X. Now that I've factorized here fully, I'm going to be looking to see what is common here between 2X and 6. 2 is a factor. What is left? When I take out the 2 from here, so we have X left. When I take out 2 from the negative 6, I'm going to have negative 3. But I want you to always remember that whatsoever is in the bracket here must be the same in the bracket there. Has to be the same. It must be the same. If it is not the same, something is wrong. You know why it has to be the same? I'm going to show you why. It has to be the same because I'm going to end up factoring it out. See it right here, so? That's the reason. If they're not the same, I would unable to factorize, and then the question can't go no further. It's like you making cheese pizza and then when you check us up, you don't have no cheese. It's not cheese pizza we have. You have dough or bread. All right. So now, when I replace my numerator for my X squared minus 2 and my X minus 3, I recognize that these are common. So this is what was preventing the true limit from coming out. So I need to isolate, right? Because those were preventing the limits from coming out. So what do you mean? You notice if I put 3 right here, so 3 minus 3 is 0, talk truth. Somebody say yes.
Yes, sir.
Number 3 is 0.
Yeah.
And that is 0 too.
All right. I'm going to tell you one more secret. I'm going to tell you one secret. So on a Tuesday, we always have meetings. Our meeting start from 10 o'clock this morning and done late in the afternoon. Me tired. Me know I'm not tired, you know, but it's when you don't talk to me, I'm going to feel lethargic. I want my class to be very energized, right? So I'm going to ask, in Jesus' name, forget about the tiredness. Just press pause for now one day. And then you're going to come to my class ready to learn because now I'm moving on. You think I'll come back to this next class? Negative. So no, I have to catch it now. Matter of fact, I didn't have to do this because I did this already. So let's go again, guys. When I ask if you're understanding, please just talk to me. All right, let's go.
What make you put this? Not hear me.
What make me do what?
Do you hear me?
What make
I
me do
was
what?
asking why you put it. Why you put it? You say if we saw that you put the X minus 3 under the divided number at the top. And I'm asking why you put it there.
No, because I'm factorizing. Remember this X squared minus all of this here, so you know, is the same thing as
what was at the top. So I think she's asking, yes,
bring
the
it down
denominator.
from the top, the denominator.
Yes, so she can know, yes. So this is coming from the top. The complete sum from the top.
Very good. I'm happy that you guys are seeing it. So what is happening now? This is going to be the x squared minus 5x plus 6, don't it?
Yes,
Yes,
sir.
sir.
Yeah, man. So I'm just rewriting it because in its natural sense, I couldn't use it like that. I can't use it like that because, I mean, and there's so many things in life we do that, you know. We get a little foreign $100 and we don't have no money, we go to Jamaica supermarket, you know, them have to convert it, don't. And your bill come to $5,000, but you have $100, you're gonna get back change because $100 is more than 5,000 Jamaican dollars. So you have to bring it to something that is very common. So that's exactly what it is that I'm doing. And that is common to how the denominator looks. So what I'm saying to you that I needed to isolate this is because when I put 3 here, remember in the original question, I had x minus 3 in the denominator. No? When I put 3 here, we're going to have 3 minus 3. 3 minus 3 is equal to 0.
0.
But guess what? Not only that a 0 cannot exist in the denominator, but when I look in the numerator, we have 3 minus 3 again, which is 0. So that the term here, so the x minus 3 is blocking this x minus 2. You know, sometimes I have some friends in life, because you walk with them and a par with them, you can't get the opportunity. You have to drop the friends them first before you start shine. That's the same thing with the mathematics. Real talk. So I now recognize that I have to isolate this x minus 3. X minus 3 divided by x minus 3 it cancels it out. So all I'm left with now is my x minus 2. Now that is simplified. I've already isolated what is causing my problem. So all I now need to do is to assume the value of x. Nikki, this is where we're talking about now. So I'm assuming the value of x to be equal to 3. Assume x equals 3. So I'm going to put anywhere I see the value x, I'm going to put 3. So come and have 3 minus 2. Call yourself 3, take away 2, you're going to have 1. Answer. Nikki, how you stay?
All right, I know that is it. I know that was the reason, but because of the first class, and I didn't get to finish the audio. You said when we see the LIM and the approaching x approaching 3, the 3 does not represent, the x does not represent the 3. So I was following the first thing you said in the first class. That's why I asked, how comes you get 1? If you understand the first rationality.
I think it's 2 different approaches.
Thank you very much.
Yeah.
So x is approaching 3. But because we're using the calculations approach, we're going to allow x, we're assuming x to be equal to 3. Remember I said to you, know, x is not equal to 3. X cannot be equal to 3. It is only getting very close to 3. So because I'm using the calculations method, I'm just allowing x to be equal to 3 for ease of calculation. Am I making any sense there?
Yes,
Talk to
sir.
me. Yeah, man. All right, let us move. So let us look at example number 2. The limit as x tends to 4 of x plus 1 over x squared minus 1. Look at what is happening. Let me do it over here. Let me go with 3. Watch me. So what I'm going to do is to say, four plus 1 over 4 squares minus 1. 4 plus 1 is equal to 5. 4 squares is 16. 16 minus 1 is 15. 5 itself goes 1. 5 into 15 goes 3. So I'm getting 1/3, which is the same 1/3 I have here. No, because I have a number in the numerator. Is it because since we did not get 0 over 0, comma, then it is not Indeterminate. It's not indeterminate. So the only time it's indeterminate is when you get 0 over 0. So you have to check first to see if your rational function is indeterminate. If it is indeterminate, then you have to do one of three things: a factorization, a simplification, or a rationalization. So you can isolate what is causing the problem from occurring. You know, I keep saying to you, mathematics is real life, When you have a fever, where the fever tell you say, come mummies. The daddies may not know. When you have a fever, mummies, wait, tell you. If your child has a fever, what is it saying to you?
You're sick.
But a little bit more than that. That there is something, there's a foreign.
Something that causes fever.
Yeah, man.
There's a bacteria,
some bacteria, some virus or something. So there is a foreign something in the child's body that is causing the fever, don't it? And when you give the child Panadol or Setamol and the fever still a galong, you say, no, man. And you give the child a water bath, ice cold bath, and the fever now cut, you say, no, this is serious. I have to go carry the child to the doctor because it could be a viral infection, you don't know what it is. And there are so many things: COVID, hand, foot, and mouth, the flu, whatever it is, but you don't want the child to overheat. So you have to go and do the necessary stuff. So I'm saying to you, when you have a fever, it tells you that something is wrong. When you get it to be indeterminate, it is telling you that something is preventing the true limit from coming out. So therefore, you have to go ahead and isolate what that thing is. So the point I make it is, in this case, it is not indeterminate. So there was no need for me to factorize, rationalize, or simplify. But what I did was to factorize the expression. We all know that x squared minus 1 is known as the difference of two squares. Little school mathematics. I'm not here to teach you that. I'm also a teacher of Foundation 1, 2, and 3. But you guys pass that stage, you're at Calculus 1. So,
sir, I've always heard of those subjects, heard of those courses, and wonder what they were,
No, just foundational courses for those students who may not have passed CSET mathematics. We try to bring them up to a level that is good enough for them to move into the other math courses.
Okay.
And all tertiary institutions have those bridging courses. All right. So let's go. So I made a notation here that since you did not get 0 over 0, it suggests that the question is not indeterminate. Watch your, at the same to my right. Yeah. Therefore, there was no need to factorize, simplify, or rationalize. The question done. But guess what? If I wanted, and because we're bright, I will factorize the x squared minus 1 as the difference of two squares. We can cancel this and we can cancel this. So we're going to have 1 over x minus 1. See the 1 here, so? Because when we cancel this and cancel this, we're going to get 1 over 1. Now, anywhere in the function, Nikki, having isolated what it is that I believe is going to cause a problem, anywhere in the function I see x, I'm going to assume it to be the limit here, so. So I'm going to assume it to be 4. So see, 4 minus 1, a 3. So if I do it both ways, I still end up getting my 1/3 as my answer. Talk truth.
Well, that's right, sir.
All right. Good. All right. Now, I want you to try this one here for me, number 3. I'm going to give you 3 minutes. I want all of you to try number 3 for me, please. Quick and fast. Get an answer yet?
Yeah, same answer.
Nikki, I don't know if that message was long time, but I'm seeing in the chat, Nikki, that you see how I get the one now, Nikki? Dottie,
Indeterminate form.
Didi,
Sir?
have you asked it to, have you, link Nikki for me, please. She sent something, she not hear me so well. Just link her and ask her if she understand how we got the one.
Yeah,
Because
yes, sir. She's the same person who was asking about the one, you know, how you got the one, because she was listening to the video and she didn't understand that part. So she's the same person when you explain it at the bottom. You want to know if she understand now?
Right.
All right, no problem.
Thank you, hon.
I wrote it out.
Mm-hmm.
She understands, sir. She replied, said that she understands now.
Okay, great. Thank you.
You're welcome.
Yeah, I was saying I wrote it out and I found that it was undefined. And when I put it into the scientific calculator.
Hold up. Don't say undefined.
Undetermined.
Indeterminate.
Indeterminate form.
Okay,
Yeah.
indeterminate, right. And when you put it in the calculator, what now?
I get the same result.
You get indeterminate, right?
Yes.
Aha. So that's why when you ask the question, that when you try to solve the stuff using a calculator, I was very reluctant in responding, because sometimes it is what you put into a device is what you can get out of it. So if you don't put in the stuff correctly in the device, you're going to have a difficulty getting out what it is that you're supposed to get out, because the truth is there's no calculator that can evaluate a limit for you. I've never seen one of those. I'm not saying that it's not out there, you know, right? You can have a solver, but you have to be careful with the solver, because sometimes the solvers don't read what it is that you are using correctly, all right? Because it's what you put in, and there's a special way for you to type into the solver. So if you don't put the information in correctly in the solver, it gives you the solution for another question. All right, so let me hear now. So I gave you the limit as x tends to -1 of x plus 1 over x squared minus 1. But hold on, sir. You think you smart enough? Because you just come to class in the evening, so after me have a rough day for not up my head. Sir, number 2 and number 3 are the same question. No. Yes, sir. Sir, me seeing x plus 1 over x squared minus 1 is the same question. No. What's the difference, sir? Thank you for asking. In the first one, the limit was going to 4. In the second one, the limit is going to what?
-1.
-1.
It therefore makes the question different. Is the function the same? Yes, it is. The function is the same. So in a case like this now, -1 plus 1 is 0. All right, we could try the denominator now. -1 squares. Oh, when you multiply two negative numbers, you get a positive number. So -1 squares is +1. +1 minus 1 is 0. Sir, indeterminate. All right, good. So it therefore means that there is something in the function preventing the true limit from coming up. We need to find that something. Because if we don't find that something, we can't work it. So,
Sir?
Yes, Papa.
For this question, for number 3, I've got 1 over -2.
1 over?
1 over -2.
All right, we'll check.
1 over -1.
Oh,
all right, we'll check to see who is right. No problem. Oh, Rockstone. What is it? Oh, me right though. Me thinks I me have the answer right there, you know, so that's why I'm scrolling. All right, so let's go. Let's write. Because we don't know what the answer is. So let me put a little space in betwixt so that I can write.
Yeah, because I'm working besides, you know.
So what I'm going to do, I'm going to factorize. So I'm going to recall x squared minus 1 is the difference of two squares. Oops. That is x plus 1 times x minus 1. And we saw that up here already. All right. So now my question is going to be the limit as x tends to -1 of x plus 1 in the numerator, and I'm breaking up my factorized form into x plus 1 times x minus 1. And when I look at that something, let me say, you bugger you, look here. When x is -1, when x is -1, this -1, when substituted in here and here, here says okay, no, but here says a problem, because -1 plus 1 is 0, and 0 times anything is 0. So it gives me a 0 in the denominator, and a 0 cannot exist in the denominator. But guess what? It also gives me a 0 in the numerator, which gives me my 0 over 0, my indeterminate form. However, when I isolate these two, because I can cancel them because they're very similar, I am going to be left with
x1.
Right. The limit as x, there.
But still, sir.
Yes, Papi.
You still won't have to calculate it anyway.
Yeah.
As -1 minus 1 would have still come to would have come to -2, right?
Okay. We think I'm gonna say 0 now because we're gonna take away lunch money for the rest of the week. So that's what I'm left with. I'm going to be left with 1 over x minus 1. Now, when I substitute the value of this x for -1, I'm going to end up with 1 over -1 minus 1, which your answer is going to be -1/2.
Sir?
Yes, Papi.
Sir, how you got this x right here? So you have the limit.
Which x, Papi? This one?
The right here. No, sir. As you come up with the green is, I have determinant. Yes. No, sir. Come over to the right-hand side of your screen. Right here, sir. We're working out.
Over here, sir?
Yes, sir.
When we get that x here?
Yes, sir.
Yes, sir. Remember, this cancel out and this cancel out. So I'll be the one who say, okay. So the okay one may I carry back in a seater, x minus 1.
Oh, because I didn't do it like that. All right, sir.
Yeah, man. And the okay one may I carry back, because the other two them cancel out. Other two them cancel out. So I'm just leaving the one that is okay. All right. So the limit is going to be equal to -1/2.
Sir?
Yes, Papi.
All right. In terms of, in respect to marks, right, and steps for the expressions that you do, would you require us to find the determinant if the equation or if the expression gives an indeterminate before we actually find the method, the limit? Are we required to find to prove that?
Okay. I think it's a determinant, but I think he meant to say indeterminate. True or false? You said determinant, but you meant to say indeterminate, right?
Yes. Yes, sir.
Talk to me. You know, sound so sure. Talk to me now.
Yes, sir. Yes, sir.
Okay. All right. So you're not. So if I were to translate your question, you're saying to me, sir, are we required to prove that it is first indeterminate before we move on? That's your question, right?
Correct.
Absolutely. You must. You must. You need to let me know that it is indeterminate. You can't do anything for me without first telling me, sir, that it's indeterminate. That's why I'm doing something else. So it is called an algorithm. And I know for you computer students, algorithm is something that you need to know. For those of you who are doing finance, algorithm is something that you must know. So what the algorithm says, do this first, don't work, do that next. Don't work, do that after. Don't work, do the next net or something. You can't just jump something. Case in point, I have a good friend of mine that lives in Canada. And she said to me, where we live, it is so cold. Lives in Canada, but works in the United States. So she drives over to the US, and she says, if I have a bottle of Pepsi in my van, and I leave that bottle of Pepsi in the van for about a couple of hours, when I get back, it is frozen hard. I said, it's impossible. And she said, no, if I leave a bottle of water in there, it is frozen because it is that cold. And I said to her, that's why Jesus made me born right out here, so, because he knew me couldn't deal with that. So one of the things, yes, please.
Sir, sorry to interrupt you, sir, but I sent you a message earlier that I was going to be late. But
Is
I
it
just
Sherry? I'm Courage,
no,
sorry.
sir, this is Joanna.
Okay, all right, fine. I didn't see, but that's fine. So one day she said she went home and her refrigerator wasn't working. And she was like, oh Lord, I have to buy a new refrigerator and it's gonna cost me $2,000 and rare, and so forth and so on. And then fortunately, because it's that cold, the food items were not spoiled. And her thing was to call the refrigeration company to come and check out the refrigerator for her. And the first thing that the refrigerator company did was to check to see if the fridge was plugged in. And lo and behold, the refrigerator was not plugged in. So do you know she had to pay about $300 just for them to come to her house and plug in the refrigerator? Why? Because you need to check the algorithm. You're at home and you turn on a switch and there is no electricity, power coming from it. You plug in something, there's no power coming from it. And you check and say, but there's light in the other room. What is going to be your first reaction? Talk to me now. What's going to be the first reaction? Matt is real life in us.
Check my breaker, sir, to see if all of
please.
this
Yeah. Check your breaker, because one of the breaker them go to fly. Check the breaker. That's the first order of the day. Because you call the electrician to come in and imply the breaker, I'm going to charge you. So just check the breaker. Check the breaker. So the algorithm is, you have to first, you notice the one that I did up top, where I got the 1/3. The first thing I was checking for is to see if it is indeterminate. But when I check it, I got 5/15, which worked out to be 1/3. When I substituted the values, I was checking for an indeterminate form. But when I substituted the values, I recognized that I was getting 5/15, and 5/15 reduced to its lowest term gives me 1/3. So I know the limit exists and it is not indeterminate. But when we move to number 3 now, and I assume x to be equals to -1, and I substitute that value into the rational function, bam, 0/0, indeterminate. Okay, so now that I get indeterminate, what is it? The next step has to be check to see one of 3 things: factorization, rationalization, or simplification. See it right up here, so you're going to check to see if it can factorize, simplify, or rationalize. One of 3 things. If when you check factorization and it don't work, you're going to try simplification. That don't work, you're going to try rationalization. By the time you reach rationalization, you must get your answer. You must get your answer. So follow the algorithm. Let me just pause it right here. Love my computing students. I have been working with the department for quite a while now. And if you don't believe me, you can go into my channel and you can see quite a number of recordings for Calculus 1 and 2. But one of the challenges that I have with some of the computing students is that, is it because I'm a bride or I do a shortcut? And I don't follow the algorithm and I cut the chase. And when I cut the chase now, I suck them and get knocked and get the question wrong. It's not that I don't understand it enough, but you're not following the algorithm because you're saying that it takes too long. follow the algorithm, and you're good to go. Moving. I want you now to do number 4 for me, please and thanks. And hurry up, man, because I want to move into another area. Number 4.
Oh, so that question is finished, sir.
Yeah,
That's
man.
the answer.
Yeah, negative 1 half.
All of this. All right, sir.
Sir,
Yeah, man,
finish.
hearing you. Finish?
Yes, sir.
Good job. All right, hold on 1 minute, please. Come on, the rest of you.
And also some back home.
Okay, great. Thank you, Lord. Next. I don't want anybody to be sitting around thinking that I'm going to know, just come and just do the question on the board, you know.
Finish, sir.
Good job. I want you to be working. I want you to be very active in it.
I as well, sir.
Good. All right. So I think I'm hearing a lot of it. So, what's your answer?
Negative half.
Negative who?
Half. 1/2.
On negative a half. Okay.
Yeah, that's what I got.
Okay. Everybody got that?
Yes, sir.
Anybody got anything other than negative a half? And let me just pause and say something to you now. No answer stupid here. And you have to tell me so that I can be able to say, I know why you got what it is that you got, so I can undo what it is that you have been doing. So I want you to talk to me, please.
Sir,
Yes, please.
sir.
Go ahead.
Oh,
Yeah, man.
sir, I got 0 over -50. I never came late, so I didn't understand exactly what you were doing, but I read over the top one and see.
Okay, all right, no problem. No problem. So I need to address something here with you, but no problem. What about the rest of you? All right. Ashanti. Ashanti?
Sure. Sure, I got
Yes,
a half.
you got a half? Positive
Yes,
a
sir.
half? Come on, that's why you said positive a half?
Yes, sir.
All right, no problem. So come
Wait,
on.
no, sir, no, sir. Negative.
A
Negative.
positive a half is saying no. Sure, they come make a shake with some lunch money. I don't know if negative a half is the correct answer. I was checking. Ashanti? Ashanti. All right, remember when we call on an answer means that you're not there, so I'm going to put in a waiting room here. Atara? Stop. My microphone now work.
It's working just fine.
Okay, I was just checking. Sharifa? Okay. Okay.
Yes, sir.
No, it's all right, Pastor. Me know your voice now.
Sir, I don't like other song, you know.
No. I know your voice. I'm just looking at people who don't talk to me. I'm calling on them and them not answer me. But again, drop on in the waiting room, watch and say, don't you think me a joke? Or you're not supposed to come to my class and sit down and pretend cute. Tony Ann? Oh, you know. All right, guess what? Me get mute, you see? And when you're ready to talk to me, you can come back. I'm serious about it. You're not too out.
Sir, they're giving extenuating circumstances that they're at work.
So we have to wait until me get mental before me hear this. Nicole has been talking to me, but fear battery
Yeah,
are
they were
dead.
already in the chat.
Oh, when me now, when if you tell me that, when you must talk to me, you know, remember me don't tell you my limitation already, you know, when me teach me now, I'm not time to check the chat. So you must set the chat and talk to me. All right, I forgive you guys. But only Tony and Atara, what happened to the rest of
Sir?
this? Ashanti, I'm call upon Ashanti. Ashanti, they work too?
So you hear what I'm saying?
Go ahead, Papa.
Sir, I think I named something terribly wrong. So I multiplied and I got 0 over 105. I think I'm doing it wrong.
Oh, you just don't know to multiply. That's the problem.
Oh, okay, sir.
Hold on. Mr. Sylvester, let me call you back in a few, please. Here, I'm in a class. All right, cool. Yeah, I know you responded to my missed call earlier, but that's who called you. Oh, Lord Jesus, help me. How do I deal with these students? All right. Students,
So I'm
get
not finished yet. I'm just trying figuring it out.
all right, no problem. I have many more questions. Let me just go through this so I can help you to figure out. I have many more questions that I can give to you. Let me say this one more time.
Sorry, repeat for me, please.
I'm going to say this one more time. In my classes, there is a positive correlation for students who participate and then passing the course. Positive correlation. It means say those who participate in my class will pass the course, and the ones who, and I've seen it happen so many times, the ones who just come to class and sit down, and that is selfish. Very selfish, because when the others are asking questions, you are benefiting from those questions and the answers that I will give. And you just sit down there and nobody can benefit from you. That's selfish. But it's all right, man. Let me tell you one of the strategies that I use. And let me tell you before I do it. One of my strategies is that when I call upon you, I always have test papers available. Like right about now, we can drop that test on this and say, work it, and I'm collecting it at the end of the class. I'm going to set you on a turn on the camera. Come on, watch my work. And when I mark it, it go towards the final grade. I do this religiously. It's since because we're in a COVID right here, so why I stop doing that? Every class time, students at the end of towards the end of each class, student normally get a 1-question quiz from me. All right? Please, if you're having a limitation, let me know. And for those of the rest of you in the class that are talking to me, just help me watch the chat, because I have this when I'm teaching and writing and support the chat, and I know it's a limitation. I know I have to get over it, but I've been trying for 2 years and it can't happen. Sometimes I see it, and there are times I don't see it. But please help me out. All right, let's go. So I would recognize that it is of an indeterminate form. The function is of an indeterminate form. So how do you know that? Wherever I see x, I'm going to assume that it's equals to -5. So -5 plus 5, see it right here, so will give me 0. And this is going to become -5 squares, see it right here, so.
Sir?
8.
Sir, so why didn't you simplify the x square, as in you have x plus -5 and x minus -5? Because I didn't like that and I didn't get the answer.
Okay, Mikey, you remember the question? Okay, mute for me, Mikey, your background. You remember the question? I think it was you, Mikey. The question I asked about if we have to show the indeterminate. Is you the ask the question, Mikey?
Sir?
Is you ask a question about if we have to show the indeterminate form?
No, sir, I don't.
Who asked that question? Somebody asked me that question earlier.
What was I, sir? Thomas.
Oh, Thomas. Okay, that's is it Dale? Daniel.
Yeah.
So Mikey, Daniel asked a question earlier, sir. When you're doing a question like these, should we show the indeterminate form? And my answer to him was what, Daniel?
Yes, absolutely.
Right. So Mikey, that's exactly what I'm doing, Papa.
Sir?
I'm first checking to see if this is going to be of the indeterminate form. If it is of the indeterminate form, I will get 0 over 0. So if I do my substitution and I don't get 0 over 0, that's the end of the question. But if I get 0 over 0, it means that there's something else that must be done, and I have to now do it. I heard that, sir?
Yes, sir. I got the 0 at the top, but the working out at the lower one, I didn't get the 0.
Come, let's work. Let's
For
work
the lower
together.
parts, I got -50.
-50. Did I do something wrong? Let me check.
Sorry, I think the reason why I got
I don't know if
105 is
I
because I
did
don't put it in
something
properly in
wrong.
the calculator.
What is negative? Aha! Because into say your calculators are all cheap. You put in your
So when it
calculator
What a
straight up.
disrespect.
No,
Sir.
straight up. No, hold up. And if
No,
when I tell you that what it is that you would have done and it don't work, I am one of those teachers who love to say I'm sorry. So let me go.
Sir, I use brackets and everything for the scientific calculator and I got 50. Negative
And that's
50.
fine. And that's fine
Sir,
because
I
you,
got 5/2.
Rockstone. Okay, it's if you're using a
What's
cheap
the burn rate
calculator,
calculator?
if you're using a cheap calculator and you just put this, the cheap calculator is going to only recognize this and it's going to tell you that your answer is negative 25. All of you just put negative 5 and then square that and tell me if your calculator gives you negative 25. You need to know, so you need to do it and let me know.
Sir,
Hmm?
sir, I think their calculator skips some necessary steps in the expression.
Yeah,
Sir, I
but
was wrong.
say that again, Jay.
Sir, I was the one typing it wrong. Sir, I got 0/0 when I typed over again.
I know, but hold on there. I may know that, JJ, but guess what now? It's an exercise, and I want the rest of them to do that. You know. Put in your calculator negative 5 and square it and tell me what you get. Anybody get negative 25?
Yes, sir.
No, okay. 25.
Anybody at all got positive 25 when you do this algorithm that I have up here, so?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And you got positive 25?
Yes.
No, me never say must do this, you know.
Oh, without the bracket?
Yes, man.
Okay.
Just
Yeah, I get 25. I get 25, sir.
positive 25.
When you put the parentheses, you get positive 25.
No?
Mine's a negative.
Your one's a negative.
sir.
Yeah, man.
Yeah.
Sir.
Right. Okay. So yours is of the cheap brand. Never mind. Don't worry about it. Who said I got positive 25 when I just put minus 5 all squares?
Me, sir.
Davy.
Okay, so Tally, what type of calculator you have, Talia?
Sir, I'm at work, so I'm just using like a app.
Sure, I have a sharp scientific calculator.
When I use a bracket, sir, I get 25.
Yeah, man, we know that. It's just that okay. So all right. So I hear all of you. The point I'm making is, if you don't use your parentheses, you're going to end up with a negative 25. And if you do that, your calculation is going to be wrong. I am saying this to you because you all need to know this, because you need to know how to access your calculators. Now, some calculators have a built-in syntax error. So let me just check my calculator and see if what I'm telling you is true. Well, I put in negative 5 all squares and my calculator gave me negative 25. So one or two calculators are built-in syntax and it may recognize a negative sign, but for the most part, if you don't have your parentheses, it's not going to recognize that negative sign. It is only going to recognize the 5. So it's going to give you negative 25 as your answer. And you will go through and write negative 25, and I will see it on paper and know exactly where you got that. And I'll mark you down for that line, but I'll use your incorrect answer as a negative 25 to see if you correctly use that incorrect answer and give you 1 or 2 marks out of the question. Right? So you have to make sure always use your parentheses. And that's why when you see me project anything on the screen, you see me have my parentheses there. So negative 5 all squares is going to be equal to positive 25. And 8 times 5 is 40. So it's going to be negative 40.
Negative
Plus
50.
plus 15.
Negative 25 minus 40 will give you negative 15 plus
And
15.
negative 15 plus
would
15 is
give you-
equal to 0. So it's indeterminate. So we need to perform one of the following methods: a rationalization, a factorization, or a simplification.
Simplification.
One of the three must be done. All right. So I'm going to look at my factorization. Sir, why? Because I recognize that my x squared plus 8x plus 15 is factorizable.
Trinomial.
It's a trinomial. Very good. The coefficient of x squared is 1, and I'm going to multiply by the constant. 1 times 15 is 15. You see, I put in the 1 in blue this time, so you can see it there. Look at it.
Yes.
Yeah, man. I put in the 1 there, so you can see that it's there. So when I do my factorization, and I'm not going through that factorization, you're going to do the step for me. Follow the 1 up top and you do the step. My final answer is going to give me x plus 5 times x plus 3. X plus 5 times x plus 3. X plus 5 times x plus 3. All right?
So 8.
Right. So good. So the factors are going to be 5 and 3. And then now I'm going to rewrite it as x plus 5 in the numerator. See there? And the denominator, I'm going to substitute this here in the denominator. All right? Now, so what happens is that you will recognize that the x plus 5 cancels. The x plus 5 cancels. So you're going to have 1 over x plus 3 left. You're going to have 1 over x plus 3. And then when you have the 1 over x plus 3, anywhere in the function you see x, you're going to put negative 5. So negative 5 plus 3 is going to be equals to negative 2. So your answer again is going to be negative 1/2. Very good. Courage. Very good. The rest of you that got the negative 1/2. Excellent. All right.
Sir, can you hold on a second, please?
Absolutely. Those of you who would have gotten the negative 1/2, move on to question 5 while I hold on Joe.
So yes, can I scroll back up, please?
Okay. More up?
Yes, sir. Question 4, the start of question 4. Okay, sir, you can go ahead.
Sir, can we go back down to the working out, please, for question 4?
Right here?
Yes, sir.
While you guys work, just lend me one of your ears.
Sir, can I see the question, please?
Okay. Let me reduce it so that you can see everything at once. Because I'm going to be going back and forth. I want you to lend me an ear. That's as far as I can go.
Sir, can go down.
Can go down some more?
Sir, just let us write out the questions and then you can put it back.
Okay.
It's question 5 I'm talking, sir. Question 5. Question
okay.
5.
Got you. I was slow right there. Forgive me. Yeah, so what I want you to do for me, I know some of you only reopen your calculus books when you came to class tonight. Some. The ones who will pass the course would have gone through what it is that I would have sent you. What's the point I'm making? The only way you can pass this course is unless you do a lot of work outside practice. Even when you do the question and do the question and get the question right, write down the question on one different piece of paper and try to do the question out of your head. You have to practice, practice, practice. That's the only way you're going to get it. If you don't practice, you're kind of dark. Oh, and by the way of information, your common coursework piece for Calculus 1 is already prepared. Matter of fact, I'm going to add it to Editor Saw. Your final examination for Calculus 1 was already submitted. So I'm ready for you. Ready like Freddy.
Oh, sir, that is good tidings, but sir, I can't see the question 5. Your viewport is much different from ours.
Say it again.
Your viewport is much different from ours. Yeah, so if you could scroll down, that would be good.
Okay, just let me know when it's my answer. So let me just.
So that's a negative one at
Sir, sorry.
Yeah, it's a negative one.
The practice is, I've been doing the practice. The homework, we should start submitting the homework to you, sir.
Yeah, just click. When you finish your homework, just click done. Once you click done, I'll get them.
All right.
Yeah, man, just click done.
They talking echoes up?
Yeah.
Oh. Wait, from when it was home?
You have jokes.
From last week. Okay.
Come, Nikki, you're too silent, you know, Nikki. Come on. You drop asleep? Nikki gone. Harris, what is that answer for this question number 5? That's the answer you got for question 5? Oh, so what was that? Oh, got you. When you were multiplying the negative 5 squares, got you. Now to check and see if Nicole all right here, because we don't want to get vexed and say she's gonna bed.
It's in a taxi, sir, and our battery is dying.
She did say that, yeah. I feel like it did because she's not in the class again.
So I finished question 5. Yeah, I finished.
Great. What you got for the answer?
Sir, 0. 1.
You got numero 0?
Sir, I don't know how I get 0, but I got 0.
You don't know you get 0, but you get 0.
Yeah. I got 1.
You got 1. Okay. Courage. Ashantio, I'm calling upon you again. What did you get for your answer? Are you one of those who are at work?
1,
Say it again. Oh, sorry. Hold on. All right.
Yeah, I was saying that
I'm hearing you now.
I got 1.
You got 1. Thank you, hon. Tajay, what you get?
Still working on those questions, sir.
Still working. All right. For those of you who got 1, very good. The rest of you now need to work it to get 1.
Sir, I got one.
Good job. Excellent. Excellent. Let me ask you, is this difficult? Is it that you're understanding or not understanding? What challenges are you having? I need to know so that I can find ways to help you. What is the issue? Are you all understanding, or is there someone in the class not understanding?
Sir, I'm not understanding.
Sir, I'm
some of
not
the stuff.
understanding.
Okay. All righty. What let me ask the question? One by one. What are you not understanding?
Sir, are we going to do to find out the indeterminate day, sir? We should use any one of the forms, or we should use all three of them, the methods.
Okay. So I think you come back again with the determinant. Determinant is a different concept in mathematics. Indeterminate. So I want you to get that right, Leon?
Yes, sir.
All right, good.
What I'm
So,
not
let me
getting,
ask
because
the
I was
class.
there. I was here
No,
trying to add. Okay.
I'm coming to you, Lottie. I'm coming to you, hon. Leon, sorry, not Leon. Class. So Leon is asking, what I'm not understanding, sir. After I get the indeterminate form, do I have to use all three methods? Factorization, simplification, or rationalization? What is the answer to that question? Class?
Just one.
Just one.
One method.
Just one. So if factorization don't work, then I move to rationalization or simplification, and there's no particular order either. It's just one of the three methods that will work. But when we look at the question, we see that the question is a trinomial. And what we normally do with trinomials, we never normally simplify them, we factorize them, talk truth. Talk to me, no man.
That is normal.
Say it again. Right, okay, yes. Leon, unmute, Papa.
Yes, sir.
You get that now?
Yes, sir.
You sure?
I think so, sir.
All right, I think so, good. Lottie, your turn.
Yes, sir. In previous class or above, you said where we have the 5 and the 8. I'm trying to find a number that you can multiply to get the 3 and one that add to get the 5.
The 5 and the 8.
No,
I'm
man,
seeing.
the 3. Something that you must add to get I think the 5. 2 numbers to add to get the 5 and 2 numbers to multiply to get the 3. That is number 5 I'm talking about.
Yeah, it is always the coefficient of x squared that you're going to be multiplying with by the constant, and then that product you're going to be finding 2 numbers. You're going to be factorizing, finding 2 numbers. When added, will give you a middle number. I'm going to say it one more time, but I just want to let you know that that concept, again, is going to come up when I'm doing stationary points. Applications of differentiation. That's unit 5. Whoa. That's a distance from now. Oh. Yeah, so I'm going to be multiplying the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. Every single time.
Yeah, I get one, sir.
Right, good job.
Sorry. In regards to Edicasa, sir, I checked to see like the assignment list. And when I checked it, I didn't see. I'm looking on I don't see anything for me.
No man, it's there for everybody. When you log on, you got all 5 green ticks.
Yes.
It's there. Go, log out and go back. It's there. It's been there from last week. Look at this, guys. So this is my unit 5 on applications of differentiation. We're far from here, but I just want to bring a point to you. When I reach at a particular point in this question, I'm going to end up with a trinomial again. See here? 6x squared plus 6x minus 2. And so I say, recall to factorize the trinomial above, we multiply the coefficient of x squared, the number in front of x squared, by the constant, the one that stands alone. So this year, I'm going to come back for haunt me. And this is unit 5 out of 7 units. And there are other areas in the course. Matter of fact, I can tell you in unit 6, it will come back again. So you must be able to master your factorization. When I ask you, I tell you. Because if you don't know how to factorize, you get about 2 points from up here, so. And the rest of the question down here, so, is 18 points. So the question long? We not finish the question yet.
Wait,
we
what?
not finish the question yet.
That's
the question done yet. See the question finished right here, so? The question done right here, so with the graph. Up the top part here, where the factorization is, only 2 marks are going to get right here, so. So if you not factorize something properly, you're going to get 2 out of 20.
So this is why I say practice.
Yeah. See the question is again?
Sir.
You're going to work something, and when you work something, you're going to get something in here, so. See the point here, I'll put the marks in there. When you do that, you're going to get this.
Sir.
2 marks. Yeah.
You can zoom in a little bit more, please.
You want me to bigify it?
Yes, sir.
So I'm saying to you, it's going to come back to haunt you. So the factorization is going to be there. See it right here again, the factorization, well, not going in a trial and error, right? The factorization is going to be there to haunt you, right? So it's something that you must know what to do. All right.
All right. So, sir, can I share my screen? Because I'm at Edicasoft right now.
Give me half a second. I'll come in. Half a second.
Right.
So you all got the 1, right?
Yes, sir.
Yes, sir.
Is there anybody in the class that didn't get the 1?
Sir, I got it, but I have a burning question.
You have a burning question. Okay, let me hear that burning question. Wow.
Since it is important and not trifle, I'm going to ask what is the constant, and another question. Is it okay if we have the 2 brackets beside each other, you know, that last stage in the factorization process, and you have a coefficient still at one point in x, right? Beside x, have a coefficient of x. Is that still important? So the first question is, what is the constant? Because I said we need to multiply the coefficient of x by the constant.
We don't like your question, them, Danny. Your question, them hard. So we don't ask to repeat. We don't like your question, them. You have to take it. You have to take time in me. So one by one. When you say the 1 we're talking about, start the question again and take time with me.
Sorry, sir. I was saying, maybe I'm convoluted. I was saying with the, yes, so what is the constant? I don't know.
Okay, all right, so press pause. The constant is a term that stands alone. So this, I have 3 terms, which is why it's called a trinomial. So you have a binomial, a trinomial, a quaternomial, and you know, we don't even really call it a quaternomial, because once it is that we pass the trinomial, we just kiss with it and say, sure, polynomial. Once it is that we pass 3, we can talk about a monomial, a binomial, a trinomial. We're not going to talk about a quaternomial. That's a type of tongue. We just say polynomial and done. All right?
Yeah.
So in this, you have 3 terms. You know, the first term here is x squared. The second term is x, but this term here is positive 15. There is no x term to it. So we call it a constant. This value will never change. It will always be 15. This value, on the other hand, will change depending on the value of x. So is this one, but this value is, case in point, it's like you having an overhead cost. You know, say your rent is $15,000, That not change. So anything you do, make sure so when you get to pay, you have to go to $15,000 because that is the rent. What will change is your light bill, your water rate, your food bill, your phone bill, talk truth.
Yes, sir.
Yeah, man. So the constant is what stands alone. Next question.
Okay, so the next question is it okay or is it normal if you have, or you're at the last stage of the factorization process, like, sir, right there, you can go up to the next page, the upper page. Up, yeah, right there. So you're at the last stage. If, for example, you have a 2x plus 5, is that normal because you have a coefficient? Is that normal?
Yeah, like 2x plus 3. Yeah, normal.
Oh, there it is. Yes, I got that, and I was wondering because it's strange to me.
Yeah, man, it normal, man.
Okay, so
Yeah, very good. Next question.
Yeah, it's for me, sir.
Oh,
So-
okay. All right. You wanted to share your screen? Are there any other questions? All right. No. All right. Go ahead now. Share. Let me see.
Sir, it's not showing me calculus on my thing.
You're not showing the calculus on what?
No, it's not showing my calculus on Edicasoft.
Meeting suggest me. All right, so see my screen right now, sir, right?
Yeah. I soon talk to you, Joe. We'll talk. Yeah. Go back to home for me, please. Home. Click on change course on it, please. The top right hand corner. Change course. Let me see something there. Are you doing multiple math courses? Okay. And you gave me your information in the WhatsApp group, right?
You have my email and my phone number, sir.
Okay.
I can send them again if you want.
No, man, that's fine because I'm seeing you on Edico, so that's fine. It means that you're there. Click on change course for me, please. Let me see something.
Roswell, are you sharing a next screen?
No, I'm sharing the same screen.
I'm not sure why I'm
Yeah,
not
it's-
seeing. Okay. It means that I'm seeing it now. I'm seeing that you are. Scroll down and scroll up for me.
Yeah, I scroll.
It means that you are not, you don't have access. It means that you use Educasoft in academic year 21-22, which is last school year. It means that you don't have access to Educasoft this semester yet. So I don't know why, because all the students who gave me their information, I would have put them on to Educa. All right, so you need to, yeah, the last time you used Educa was semester 1, academic year 21-22.
The last time I actually used it was semester 2.
Yeah, it's in term 1. Don't know what is happening there. All right. All right. So I will fix that for you. Let me just check something in the group. What is this group again?
Calculus 1.
Calculus 1. Sure for this. Calculus 1. Cross Crossville. All right.
We just send out my email.
Please do, because it's not in. You never sent it to me before.
That means when
I
you put.
look in the group. I'm looking in the group.
That means
And there were 17 names that were sent to me initially. Yours is not one of the 17 that I just counted.
Okay. Well,
Yeah.
let's say it again.
Yeah, please send it now, and then I can have it added afterwards. And the rest of you, make sure that you.
All right, we just said all go.
All right. No, I don't see it yet.
Wait a second.
You may have sent it in the chat, but not the group. But anyhow, okay, you're typing 4160. No. All right.
Oh, I forget to turn the Wi-Fi on phone. So
okay. All right. No. Okay. All right. So I will get you guys. Those of you who don't have it, yes, Chetty, thanks for putting that information, Chet. Right, so if you don't have access to Editor yet, just put the information in. I can take a 5. I'm going to speak to somebody immediately following class, and then I will just go ahead and add it. All right, I'm going to end here. I'm going to ask also that you guys go through what it is that we have done. Students, you can't wait until the appointed time to start preparing, or else you're going to fail. You have to start the preparations from now. I'm going to send you a few questions tonight, and I'm going to ask that you attempt those questions. You don't have to do them tonight, but attempt those questions before class on Thursday, God's willing. That's okay?
Yes, sir. That's fine.
Yes, sir.
All right, have a nice day. Later.
Thanks, sir. Same to you.
Yeah, Keandra?
Same
No.
to you, sir.
Yeah,
Same to you, sir.
yeah, bless up.
Remember to add Joanna and edit Kosoft.
Yeah, Jojo, send me the information, please. Drop it in the WhatsApp group. All time.
Okay.
Sir, the recording as soon as I get it, sir.
Always. Have you checked the last 2 recordings?
Yes, sir, I did.
Okay, no problem.